Okay, so connectivity and paths. I already kind of allude to this, but to be more explicit about it. Okay, so connectivity and paths. So if this is A and this is C and this is B, then there's a path from A to C, and the path is of length 2 because that's how many vertices are in the middle here. So a path is a series of edges from one vertex to another with length. With the length of the number of vertices, or the number of edges. Also, no vertices or edges are repeated. There are two related concepts. A trail allows for edges to be repeated. Sorry, vertices. But not edges. And a walk allows for either. So if it's a path, then it's also a trail. And if it's a trail, it's also a walk. And I'll give you guys an example of. So here, we'll look at K4 here. If I want to get from this guy, A, B, C, D. If I want to go from A to C, then I can go here. And that is I'll try to change colors here, see if that's a bit more visible. That's a not very efficient path, but it is a path. The most efficient path is just this guy right here. But this is also a perfectly valid path. But if I were to do something like this, I'm going to undo that because that's, if I were to do loop around here and then go down, then I would be repeating vertices, but I would not be repeating edges. So that would fall into the middle ground. That would be a trail. And if I were to go that way, that would just be a walk. That would be neither a trail nor a path. But in order to, if there exists any of these between any two vertices, then our graph is connected. If not, then it's disconnected. So if I were to give you the if I were to give you that as an image of a graph, this whole thing right here, this is disconnected because I can't get from, say, this vertex to this vertex. In fact, these guys are both what are called trees. A tree, so this right here would be considered a tree, and this right here would be considered a tree. Together, if you have multiple trees that are not connected to each other, then what you have is called a forest. So a tree is a graph that does not contain a cycle. So cycle on an intuitive level is exactly what it sounds like. Something like this. And if a graph contains a cycle, then that means that this is a subgraph of it. So this would be a graph that contains two cycles and is therefore not a tree. And a formal definition of a cycle could be there exists at least two paths between a point and another point such that they do not overlap. So if I want to get from here to here, I can go here, or I can go here. And that's two different ways to get to that point such that they do not overlap.